Alright, so we're going to start off with a really simple rational equation here. Here's our rational function. Now, domain. Without looking at your graphing calculator.
Okay.
Let's find the domain. Who can tell me what I do to find the domain?
Denominator zeros.
Okay, so the denominator equal to 0. So we know, well, not equal to 0 really, because x cannot be negative 2. So since that is our restricted value for x, that helps us with our domain. We know it cannot be negative 2.
Gotcha.
That is our restricted value. So that would be your first step. Yes?
Would you count off if we didn't put the little U thing?
Yes. When we have multiple intervals for a domain or a range, you would want to join them with the union symbol.
That would mean you're multiplying them if you don't put the U.
Okay.
You got me.
The next one is vertical asymptote. Nice that it lines up right after domain.
Just one.
Because the vertical asymptote is the same as the restricted value on the domain. Okay, that's vertical asymptote. Alright, so we know we can come in here and sketch in our vertical asymptote at x equals negative 2. Alright, so it was fine, he was just a little bit ahead of the game. Okay, so the next question is horizontal asymptote.
Okay,
Alright,
guys.
so Carson, what do we look for a horizontal asymptote?
The zeros of the numerator.
That gives us a y. We'll talk. That gives us a 0, but not the horizontal asymptote. So when we look at our variables, we have same degree in the numerator and denominator. What was our rule when we have the same degree?
It's leading coefficients.
Divide the leading coefficient, so it is y equals 1. So we have a horizontal asymptote right here at y equals 1. Now, could it be possible, on a complex function, to cross a horizontal asymptote?
Yes.
It can. This one doesn't, but it can. Okay?
Seems legit.
Now, zeros. The zeros just help us kind of get an idea about the form of the graph. Okay, so what is the 0?
X equals 4.
X equals 4. Okay? So now I have everything I need to do my interval work. Okay, yesterday we called these critical points.
That's why.
Sign chart, interval work. So we're looking at the intervals over which this function is positive or negative. And the critical values that go on this sign chart are our 0 and any vertical asymptotes.
Why'd you put 4? Why'd you put 4 on the left?
Because I had a moment.
I was like, what?
Okay, sorry about that. I didn't put them in the right order. Okay.
Just flip them little numbers.
I did. Okay, so let's test. A number that lies in this interval from negative infinity to negative 2. Say negative 3. I get a negative divided by a negative is a positive. Okay? Let's choose a number that lies in this interval. Say 0. A negative divided by a positive is a negative. A number that lies in this interval. Say 20. A positive divided by a positive is a positive. So I know where my function is positive, and I know where my function is negative. I know I have a 0 right here at 4. Now, let's figure out my y-intercept. I plug in 0 for x. Okay, so you do r of 0, and I get negative 4 divided by 2 is negative 2. My y-intercept is the point 0, negative 2. Okay.
Yeah.
Now, it is. It is going, we know it's going to ride along this over here, right?
What has to?
Because the horizontal asymptote basically is telling me about the end behavior of this function. Okay? It is not going to cross the vertical asymptote. Now, we know it's positive over here, right?
Right.
And we know that as it approaches negative infinity, it's going to approach that horizontal asymptote. So it's got to be getting closer, and so we know that it's going to be going up this way.
I have a question. How did you just say one again?
How do we get this one?
No, I know you got that one.
How do we get this one? Okay, let's go back over that thought process. We're going to tie it back to end behavior. And what does the end of the function do with respect to the horizontal asymptote? It's going to approach it, and it's going to approach it from the positive side. So we know it's coming down like this. And then because of that vertical asymptote, we know it has to go up.
Okay, so
just shape.
it's gonna follow the horizontal vertical asymptote.
Yep, it sure does. Okay, grab it on your calculator and take a look.
All right.
Please, let me have this one.
If you didn't have how would you know that the other one needs to go down?
It's critical. You gotta have the Or you can't.
Interesting. How do you know
Almost.
all this funky type stuff? Like the other one.
I know
That's
it.
crazy.
Okay, person, I know it because there were no factors that would lead me to imaginary. And there's one that would get anything crazy. And you will start.
So when it's like different, like,
So Miss Mother, yeah.
I understand that, oh, okay, this is process, that's process, but why didn't you use? It's so hard to focus right now, I keep pushing
I knew. Okay, let's see. Negative right here. See, it has to be below the axis in that interval. In this interval, it's below. Yeah. So I did teach that. Okay. All right. I had a request for number 4. My plan was number 3, but I guess we could do number 4.
I think we should do number 3.
Yeah,
I'm feeling 3. 4 looks easy. Like, that's the only one that I
don't know what this
probably
is.
factor out.
What are you talking about? How do you find the horizontal axis?
Okay, let's do 4. I'm okay with 4.
Which one?
What is going on with my crazy graph?
Sorry.
Is it usually the same way?
That's just why.
No, you can't. Actually, there is no.
It's less than those.
Okay,
You get a
so,
crazy graph, you gotta do
yeah, I do have crazy, I got a grid inside of a grid on mine.
All
Alright. What are my restricted values on the domain?
-4 and 4.
Very good.
Negative.
Okay, so negative infinity to -4, -4 to 4, 4 to infinity.
So our vertical asymptotes are negative.
Okay, now what's next?
Horizontal asymptote.
Okay, horizontal asymptote. What is it, folks?
0.
No, it's, I don't think it's
Yeah,
it's
zero.
1.
It's 0.
It's 0, and why is it 0?
Oh, wait, we're doing.
Because the degree of the numerator is less than the degree of the denominator.
I told you that there was.
Okay? So, let's put those asymptotes down there.
The 0 is 0.
Wow, that's
Okay?
beautiful.
The 0 is
0.
0. Okay.
So 3 dots.
This is where the interval work becomes critical. Because otherwise, you don't know what's happening in this happy middle. Okay. We are very punny today, aren't we? Alright. Okay, so on my interval work, my critical values are +4, -4, and 0.
Okay.
Alright? I want you to see if you can find the signs. Finish that sign chart for me.
Okay, no. I thought there was I thought you had another dashed line going straight down the middle, but I realized those were the dashes.
Okay.
Oh, wait, so you use the vertical asymptote.
For the interval work, we use the zeros. Our critical points are the zeros and those vertical asymptotes. Yes.
-5, that's a negative.
Yeah.
Oh, that's positive.
Plug it there, like,
You know what I'm saying?
no, it's 0.
All right. Do you get negative
always 5.
Can we just say that they are, just
Well,
to
good.
confuse
Look
you?
We are gonna be very careful not to say always. Very careful.
I agree with you.
Alright,
Use that.
so, we know it's negative, and we know it's approaching, well, let's do y-intercept while we're there.
It's 0.
I've already plotted it, right?
It's,
0, 0.
no, it's, yeah, there is no Y or
No, it's 0.
Zero.
0.
Zero.
There's already 0 at 0.
It's already plotted.
Zero.
It's already there.
It's zero.
If you plug in 0, you get 0 divided by negative 16,
Okay,
which
so it's
is
0.
0.
My bad, my bad.
Alright, so,
I'm sorry.
Sorry, I
That was
didn't
really
mean,
neat.
I didn't mean it.
we know it's gonna be approaching our asymptote on the ends. We know which side it's gonna approach from. At this end, it's gonna approach here.
That is the best.
Is that our bill?
Okay?
Yeah.
Alright, at this end,
But
it's
you know, I
gonna approach
don't
from
trust
here.
bells and Styria anymore.
Okay, we know it's positive on this side, and it's gonna run along that. We know it's negative on this side, and it's gonna run along that. Everybody get it?
Wait, did you go
Alright.
Calculator.